Twice. 3 times. All right, so we're going to quickly go into this lesson. Okay, lesson 10, objectives. Compare and evaluate expressions with parentheses. I can. Compare and evaluate expressions with parentheses. Parentheses, yes. What does parentheses look like, you may ask? I'll show you. Parentheses look like this. Again, you see them a lot in reading, but you see them a lot in math also. Parentheses are those two things that look like two C's connecting, parentheses. All right, here's our fluency. We write 12 inches is equal to how many feet? Hey.
Anybody seen Brooklyn?
No. 1, good. 12 inches is equal to 1 foot. How many feet are there in 12 inches?
1 foot.
1 foot, good. So 12 inches is equal to 1 foot. Below it, write 24 inches. That's equal to how many feet? 2 feet, good. Now, if I go and say 36 inches is equal to how many feet?
3.
3. Good. Now, what would be my rule here?
Skip count by 12.
Okay, I see skip count by 12. I like that. Skip count by 12. Skip count by 12.
You can do repeated addition.
Repeated addition. What else? What about
LCM?
this can be, well, if we read from left to right, this can be divided by what?
12 or 10.
Right, divide by 12. Good. All right. If I say 45 inches, 48. Thank you.
4.
If I say 48 inches, it would be 4 what?
Feet.
Good. Great job. Moving on. If I wrote 120 inches, how many feet would I have? 10. Good. How do you know? Good, because 10 times 12 equals 120. So we can say multiply by what? Okay, multiply by 12. Because 1 times 12 is 12. 2 times 12 is 24. And then we can do the opposite, divide that. If we divide 12 by 12, you get what? 1. Good. Great, we moving on. Dollars. She spent 3/5 of her money and saved the rest. Good. How much more money did she spend than she saved? So how much money does Brenda have?
240.
Good. She spent 3/5 of her money and saved the rest. I'll rewrite draw for you, and you and your elbow buddy work out this problem. What does my equation look like? Oh, no. 240 what? Dollars. It says she spent 3/5 of it. What would my draw section look like?
Tape diagram.
A tape diagram. Good. Now, in my tape diagram, how much money did she have in all? $240. So here we go. This is our whole, $240. Now, we have to split this into how many units? Fifths. Good. We split these into fifths. 1, 2, 3, 4, 5. So we have 240 times, 240 times there. Now, that's the first leg of the problem. You can start on it now.
So 240. Okay. Was that
So now you gotta take 240 and split it into these.
Let's see. 50, 100, 150, 200, 250. That's 240. And
You gotta go back and take some money out of each one.
He had put 50 in all of this.
And no, but that was a good start. You should have kept it.
Wait, that was 240, not 250. That would have been the answer.
So then if you put $50 in each one, how many dollars do you need to take away to get 240? Take $1 away. Okay. So that's 5. So how many dollars would you need to take away?
10.
So you need 10 in total. So put your 50 back in there. Put your 50 back. I can give you a blue one. Good job.
Only 50?
You had all 50 in now.
I have 40.
So you got 50,
100,
100,
150, 200, 250.
Good. So now you got 250, but you're looking for 240. So how many dollars? You got $10 you need to take away, right? So how many dollars can you take away from each?
$10.
No, not 10. You're taking 10 away from the whole number that you had. How many?
I say 5.
No. So if you take away $5, so you got 1, 2, 3, 4, 5. You take away $5. That means you're taking away $1 from each. What about the other 5 you need to take away?
I need to take away.
How many should I take away from each one of those to get an even 10?
Even 10.
So let's look. If you take $1 from each one of those, you get 49, right? Then if you take another
$1
away, you get what? 40 what?
40.
You have 49. You take another $1 away, you get what?
48.
There you go. So
And
put
you take $2 from
it from each one. Yep. So that's not 50 is what? 40 what?
48.
48. Yes. Now it's telling you to do what? Like 3/5 of her money went well.
Her money
3/5 of her money
and she saved the rest.
and saved the rest. So she spent 3/5. So what's 1/5 of that? What's 1/5?
1/5
of what you have.
48.
Good.
Alright.
What's 2/5?
2/5.
What's 3/5?
96.
Good. Come on.
3/5.
We'll add these two together.
Wait. I had it. Wait. 146.
146.
Boom. Wait.
Hold on.
No,
That's not
it's 144.
144.
Ha!
All right. What about 4/5?
100. 192.
Do the math.
192.
192.
Fish.
And then 5/5 is what?
24.
240.
24.
Yeah.
You said 224.
240.
That's
So
240.
now from this diagram, tell me which one is how much money she saved and how much money she spent and then how much money she saved.
She spent 3/5. My bad.
No. So if you have an in all number, the things pay attention. If you have an in all number, the numbers in those boxes can't be larger than your in all number.
Wait, I got it. I got the in-all number, so maybe we can put 10 in each box.
I would start off. I would start off there.
We can put 10 in each box. So 15 in each box.
But is that enough?
No.
No. So erase that. Go to the next larger number up. What up? 20.
I don't think 20 gonna work.
20, because you get 20 times 5. Okay, go up. What else do you think?
Because that's how we use it. 23.
What you want is to make a number that you could work with. So let's see. The first thing I would do is I like that y'all using real numbers, right? But I would probably use place value this. Why? Because you can change the number of a place value this. So I would start out, y'all tried to do 10s, yup. And so let's look. So 10 we'll keep going for a long time, yeah? What about 20s? Well, let's see. 20. 40.
60, 80.
100. Come on. 20, 40, 60,
80, 100.
200. So we got 200 now, right?
Yeah.
Okay. Then, well, if I go...
You get right here, it'd be 240.
Right. But now we got to divide these 5 evenly amongst 40. So how would we do that? Skip count by 5s. Come on.
8.
8. Good. 8. So now I will add these together. How much is that in total? 48.
Okay, genius.
Good. Now we go back to our chart. 1/5 is equal to what?
1/5.
Good job, ladies. Good job.
So.
All right, clap once. Clap once. Clap twice. 3 times. Oh, that was sweet. Clap once. Clap once. Clap twice. 3 times. All right, so let's quickly look at what we did. So in each one of my units, I should put what number? 48. Good. Because if I was to split 240 up evenly, each one of these would be 48. Good. And then my equation looks like what? 240 what? What's my what should I do? 240 what? Operation times what? 3/5. Good. Now, when I get 240 times 3/5, I can go in and say 5 goes into 5 one time, 5 goes into 48 how many times? Well, we already found out. It's 48. Yep. 48 times. Now, I have 48 times 3. How much is 48 times 3? 140. 144. Good. So she spent $144. How much does she have left to save? So if she spent $144, how much does she have left to save? She saved $96. Let's see if we correct. All right, moving on. So this lesson is going to be very easy today. Again, we're writing an expression to match a tape diagram and then evaluating. So if we look here, the top number is our what?
Our total.
Our total, our in all number. They give us an expression as our total. What's 9 plus 11?
99.
20. 9 plus 11 is 20. Good. And then how many of these units do they have in brackets? 4. Good. And then how many brackets do we have in all?
3.
No, that's wrong. This is 3. This should be 3 because I count 1, 2, 3, and then it's 4. So it's asking us what's 3/4 of what? Of 20, right? So what? And if I was to write it, I would write it like this: 3/4 times what? 20. Good. This is how you can write it as an expression. All right. Let's go and ask some questions. So we got 9 times 11 is 20. 9 plus 11 is 20. And this we found 20 to be our what? If we add 2 add-ins, we get a sum. Great. I need y'all to pay attention. When we add 2 add-ins, we get our sum. And so our sum was what? 20. And then if we break 20 up into our 4 unit, we get what? If I have 20 and I break it up into 4 units, I get what? 5. Good. So if I have 3/4, here it is. I want to show you it. Our in all number is 20. I know our units is in 4. And here I have 5, 10, 15, 20. If I'm sectioning or put my bracket around here, this is 15. So 3/4 of 20 is equal to 15. 3/4 of 20 is equal to 15. Again, only thing that you're responsible for is writing it as a expression, which looks like this. 3/4 times 9 plus 11 is equal to 20. We went down and did the math. That's what we're going to be responsible for. Let's look at another one. It says what? What's the first thing you can actually do? What's your first verb? No, on the directions. What's the first action verb?
Circle the
Expression that gives the
Part 1. Y'all not listening. I need all eyes on me. 1, 2, 3, all eyes on me.
1, 2, 7.
Good. If you look at the paper, look at your paper, it tells you in the instructions. Yeah. And then for 1 meter, we have how many centimeters? 1 meter.
12.
Yes. 1 meter. So this is meter in the centimeters. Good. So 1 meter equals 100 centimeters. Again, centa means what? 100. A century means 100, right? Centa also means 100. All right, so here are our 3 conversions. We are getting ready to break up and do our problem set. We're going to break into our problem set groups. So right now, I want you guys to break up into your problem set groups in 5. Okay, so what did you get?
I got 4 inches for B,
Mm-hmm.
10 months for C,
Yes.
and 80 centimeters for D.
80 centimeters, good. How did you get 80 centimeters?
I had counted by my 20s,
By
20,
20.
40, 60, 80.
Okay, 20, 40, 60, 80, good.
D, C,
So our final answer is 80 here. Good job. All right, let me go check on some other groups. Hey guys, what did you get? What did you guys get?
For B, we got B is 12.
12 inches. Okay. And how would you figure that out for a third? 12 is our in-all number. Nope, this box is right. 12 is our in-all number. Yes. So if 12 is our in, no. 12 is our in-all number. Good. What is going into each one of those boxes? Yes, 4. Good job. Great. Now, if it's 4, so what's 1/3? What's the 1/3 of a foot for B? So we take, how many boxes are we gonna count, guys?
3.
No, 1/3. If I was to shade one of those boxes in, 1/3, shade the box in, what do you have? What was the number in the box? 4. So our final answer is 4. Good. You got to do the math. Okay, let's look at C. 4. So May is gonna be what? We have 5. May is gonna be what? 6. And then we can have 7 here, and then 8 here. And then where's 9 gonna be? Okay, January is 9, and then our last is what? September. Now, looking at those fractions, looking at those numbers, where should I start my line plot? My line plot is going to be broken into what type of units? What type of units is my line plot going to be broken into? What's the first thing we come to? What's number 1? What's the first thing to plot? 4s. Thank you. So here we're going to have 1 4. Okay, so here on 1 4, I'm going to have 1 X, right? Then I got 2 4s. Then what's next?
3 4.
3 4s. Oh, do I got to plot something here? I plotted this one. Do I have any 3 4s? Oh, but I have 1 what?
The whole.
No. So I'm at 1 and then I move to 2. 2 is what?
1/2.
A half. So where's my equivalent fraction for a half and 4s?
2 4s.
2 4s. I plot 1 here. Good. Then 3 is 1. So where's 1? So I got 4 4s and that is 1 whole. Good. And then I got 5 4s, which is 1 and 1 what? 1 and 1. 4. Good. And then I got what? 6 4s, which is what? 1 and 1/2. Yes. Then I have 7 4s, which is 1 and 1 what? I'm sorry, this is a half. I know we ain't did this in a while. I have 7 4s. So this is 1. Well, we know 7 4s is 1 and what? 1 what? 1 and what? 1 and 3 4s. Good. Now, I want you to look at this pattern. So I have 1 4. Then I have 2 4s, which is equivalent to a half. 3 4s and 4 4s represent 1 whole. So here's 8 4s. How many times can 4 go into 8?
2.
Twice. Good. Now I'm going to pause here and I'm going to track what I have. So I stopped at 2. Number 3, we got to put an X on 4 4s, which I did. Let's look at 4. I got 1 and 1 4, so I'm putting an X here. What else? Where's my next X going? Christian, where's my next X going? I'm on 5. How many gallons of milk did she drink? 1 and 1/2. Great. I can cross this one out. Where is my next fraction going? Which is 6, which is May. Madison. Look at May. What should I tally, or what should I plot my date on the line plot? May is what?
May.
Yes.
7 4.
7 4s, good. I like the way that how you went back to the improper version. Or 1 and 3 4s, yes. Good. Now we on 7. In July, how many times do I have to put an X on 2? How many? Twice. Good, because I see 2 2s on my data chart. Good. Now I gotta keep going, yes? Yeah, because I only got 1, 2, 3, 4, 5, 6, 7, 8, and I need to apply how many? 2. 10. 2 more, good. 9 4s, which is 2 and what? Well, 2 and 1 4, good. And then I have 10 4s, which is also what?
2 and 1/2.
2 and 1/2, great. And then I have 11 4s, which is also what? Well, I'm here, so if I had 1 and 3 4s, this would be 2 and what? 3 what?
3.
Good. And then here is 12 4s. Now, I want you to look at the pattern. So if I was 1 and 1, I was here, and then I got here to 2 and 3 4s. My next thing is going to be a what type of number?
3.
Whole, which is going to be 3. Great. Now, do I need to apply something for 3?
Yes.
Yes. What am I plotting for 3? January, good. So at January, I'm finding 3. Do I need to keep going? Let's evaluate. Do we have 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. I only got 9. I must have made a boo-boo somewhere. Let's see. 8.
September.
In September. Oh, we gotta keep going then, right?
Yes.
Good. So I got 13, 4. Yes, I did say boo-boo. This is 3 of what? 3 of what? 1 4. Great. Y'all getting better at these number lines. 14 fourths is what? 3 and a what? Nope. 2 fourths, I'll go for that. Or 3 and what? 1 half. Good. Simplest form. Jordan. Then I have what? 15 what?
15 fourths.
Which is what?
3 and 3 fourths.
3 and 3/4. Can I stop?
Yes.
Yes. I'm gonna plot my last one here. Great job. How many gallons of milk did Colette buy from January to what? October. They want us to add it all up. I think we can do it. All right. How much is 3? Let's look. We're gonna just go. How much is 3 plus 2? 5. Good. So this is equal to 5. We're not gonna deal with anything but whole numbers now. Okay. Here's another whole number. Add 2 more, which is what? 7. Good. Add 1 more whole number, which is what? 8. Good. So we plotted all of those up into 8. Okay. I did. Because I ain't even thinking about it. But I can do it today. Okay. All right. So I have 8. Now let's go back. Let's count. Let's do the halves now. How about that? So how many halves do we need to equal 1 whole? Well, actually, yeah, let's do the halves now. How many halves do we need to equal 1 whole? 2. So here's 1 half. Here's 2 halves. So that's 1, right? And then what about this one right here? Add this 1. So how many do you have? 2. So we're going to add 2 to the 8, which is what? 10. Good. Now let's look at the 4. Well, here's 3/4. How much do I have to jump to get 4/4?
1.
1/4. So here's a 3/4 here. Here's a 1/4 here. So that's 1 whole. Plus the whole we had connected to here is what?
11.
No. Pay attention. If I have 3/4, right? And then I still have a whole number attached here that I have to count. So 3/4 plus 1/4 is 1 what? Whole. Plus the one I have here, which is what? 2. So I'm going to add 2 here. Now I'm at what? 12. Good. Now, I got 2 numbers left, yes? I got to add this number and this number. Let's look at the fraction. 1/4 plus 3/4 is 1 what? 1 whole. Then I'm going to add, so I added this, and then a 1 up here makes it. So if that's 1, this makes what? 2. Good. And then this makes what? 3. So how much is 2 plus 3? 5. All hidden in our head, our final answer is what? 17 what? Gallons. Good. Yes. You did it all mentally though. All right. So we are now at our exit ticket. We are now at our exit ticket. Before we get started on our exit ticket, I want you guys to look at this. Before we get started on our exit ticket, I want you guys to look at this.
Can watch a video that helps us with our exit ticket.
1 second.
Here's my ticket.
All right. Here's the debrief and the discussion question. And we're just gonna do one. What relationship do you notice between the 2 cake diagrams in problem 1? So let's go back. What do we notice about these 2 problems? Look at problems 1. What do you notice? They both have what? Yes.
3 boxes.
They both are broken into thirds. The Tate diagram are both broken into thirds. Good. Do we notice something else? What do we notice? The second diagram is missing its in all number. Good. What else do we notice?
The first shade has a question mark, but the other one has 3 fifths plus 1/2.
Good. So the portion, the bracketed portion on one, it just has a question mark, meaning that it's only missing its fractional portion. And then on the other one, they want you to figure out what the fractional portion is. Yes? Good. You got another one? Yes. What else do you know?
I also noticed is that the first one had 8 plus 9, and the other one only had a question mark.
Good. So again, you're missing your in all number. Great. Let's look at problem 3. Let's look at problem 3. Now, we did these problems. We did problem 3 together. So share with your partner right now, the people at your group, and talk about how you could visibly come up with some of the incorrect answers. We're only talking about the incorrect answers. When you see the divide by what? When you saw divide by what on number 3, which was the incorrect answer? Good. When you saw the divide by 3, number 3. Now, what did you say, Miss Jordan? You saw the divide by what?
4.
When you saw the divide by 4, you knew it was automatically wrong? Good. What about the multiplication part?
Multiplication part?
Yeah, so look, on the ones that you have X's on it, the multiplication part equal what?
5 times 7.
Which is what?
35.
35. So that was automatically wrong because 4 times 7 was what? How much is 4 times 7?
28.
28. Good, you got it right there. Great job.
Denominator is 5, but it doesn't say 4, so we know if we divide it by 4, it would be a different number. But since we're dividing by 5, it's a different number too.
Okay.
Well, I would say these two are wrong is because if I did the same thing, I would have had 35 for both. And then when I had divided by 4, I would have got 8, and I would have got 8, and I would have got 8 and 2/4, which is 8 and 1/2 for both.
All right. So I'm gonna